Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you are new to this channel, please consider going down below and subscribing if you haven't done so already. That'd be great. Today, sitting on the desk, I've got a Scorpion Viper 20 guitar amplifier, and it's made in Australia, so it should be of good build quality, right? Right? Yeah, well, we'll find that out when we open it. And I paid $22 parts only from the Glenorchy tip shop, and they've cut the cord off as they usually do, which I wish they would stop doing that because it makes it awfully difficult to get power to the thing to actually figure out what's wrong with it. Now, I have no idea what's wrong with this thing, and an internet search on this particular amplifier doesn't bring up any results for it, so it's just an obscure amplifier as far as I'm concerned. I didn't do too stringent of the research. I just went Scorpion Viper 20 in Google and it didn't bring anything up. So I don't know where exactly this was made in Australia. It could have been Sydney, Melbourne maybe, I don't know. Don't know how many were made and I don't know who actually ever sold them. But before I'm actually going to power this up to verify what is wrong with it, I'm actually going to take the chassis out of the cabinet and disconnect the speaker driver so it doesn't get damaged by DC or anything stupid like that. But if it had DC on the output, well, the driver's probably done anyway. There is one other thing I noticed, that when I pick it up, there's something rolling around on the inside, which is not a good sign. I think it's on the inside of the cabinet, so let me go ahead and start disassembling this thing. So this is a good look at the back of the cabinet. There's nothing really exciting here. The power cord comes out through the bass reflex port, which is interesting. There's no visible serial number or any signs of one ever being on it. So if you were to resell this, say to a second-hand shop or a pawn shop, yeah, good luck, they may not take it. So I'm going to pop the back off because I'm going to need to anyway. There's 4 screws on the top to remove the chassis, but I want to have the back off so I've got some way of holding on to it. So I'm going to start by removing these 4 screws and we'll see what's on the inside. Now, is that washer going to stay behind? Probably. See, that's a really long screw. Yeah, that cut washer's going to stay behind. So I'll just take these 4 screws out and pop the back off. Alright, screws are removed. There we go. Oh, there's a piece of glass in the back of it. Well, at least it's nothing component wise. Check out the thickness of the panel though. That's a good 18 mil. That's hefty. That's why the screws were so long. That is both dangerous and random. Okay, well, we'll pretend that we didn't see that. The speaker driver is actually soldered to the wires, so I'd have to unsolder them. That looks like the power transformer, the mains transformer. So, okay, it's just a standard E-core. Nothing too special about that. There's the secondary wires there. Okay, so the actual chassis itself is held in by these 2 screws here and these 2 here. So first things first is to warm up the soldering iron and disconnect that speaker driver. Negative. Wow, come on. that is positive. Take out this last remaining screw. It's held in by the woodwork at the front, but it is loose. So, just put my hand under this, support it. And I'm going to assume this has to slide backwards rather than forwards. Well, it can't slide forwards because the transformer's in the way, so it'd have to slide backwards. So, get this last remaining screw out if I can. It seems to be stuck in there for some reason. Come on. Push it backwards. And pull it out. Nice. An amplifier is born. And as for the build quality, absolute rubbish. It's a very piss poor made PCB, and as an Australian this kind of makes me angry, to say the least, because it's the most cheapest PCB, badly cut, and build wise it also has no fuse protection. So the transformer itself would have a thermal fuse in it, and if that's gone, well, that's it, this amplifier's done. But there's no inline fuse protection anywhere, so yeah, that's pretty bad. And there's all this silicon all over the place. I'm thinking maybe just to stop it from vibrating. And it uses a TDA2040 power amplifier IC. Okay. Well, there's nothing wrong with using an IC power amplifier. They do work. However, if that's not working or it's damaged, that's going to be hard to get a replacement. Easily, anyway. Most likely it could be ordered online, etc., but you'd have to wait for it. Now the thing is, I'm still no closer to seeing anything that's obvious. So there's no carnage, there's no blown up capacitors or anything. They're only using two 1000 microfarad 35 volt capacitors. So that's going to put the power hours around about the 25 to 30 volt mark. But there's all this oil or something there. I don't know what that is. Yeah, so what I need to do is I need to strip back this power cord and connect it into some form of lead, and then connect it into the dim bulb and just see if the thing even powers up, because if it doesn't even power up, there's no point going any further with this. However, what might be a good idea is to strip back the power cord, as I just said, but just do a continuity test to see if the transformer is still intact. Alright, I've got the power cord stripped, so neutral and active, power switch is turned off, nothing's happening obviously. Power switch is on. There's 62 ohms there, or thereabouts, jumping around a bit. So the transformer's not open, so that's actually a good sign. Alright, I'm still no closer to knowing what's wrong with it, but at least I can power it up. So, but I'm still not happy with the fact that there's no fuse protection built into this thing, which might be a good idea to add as a modification. Just going to put this condom back over the switch if I can, because I pulled it off just to check that the switch wasn't open. Yeah, I can sort of get it back on there. So let's push the switch back out of the hole, but that's not what I wanted to do. Okay, cool. So, alright, let me find a way of connecting a power cord to this thing, and we'll power it up on the dim bulb and see what it does. Just going to make sure to check that these two output wires do not short together. Although it's an IC amplifier, so it most likely would have short circuit protection on the output anyway. Okay, got a temporary power cord hooked up to it. This is only for testing purposes. I'll put a proper one on later. That is if I can get it working. So dim bulb is connected to the power, so I'll turn that on. Nothing happened obviously because the power switch is off. Turn the power switch on. Well, we've got power, the light's on. And the dim bulb is glowing dimly. Alright. That is a good sign. I can't see any smoke coming off anything. So what would be a good idea is to turn it off for a second. I'm going to measure what is happening on the output with a multimeter. Just see if we've got any like DC content there or any sign of life, if you know what I mean. This is so much easier to film with the shelving unit now. Right, so the multimeter is hooked up across the output, power is off, so I'll turn it back on. Well, we've got like about 2 millivolt there minus. That's a good indication that the power amplifier IC is actually doing something. And it's not like completely dead. So far so good. I haven't measured the power rails, but that'd probably be a good idea to do next. Come across the bridge rectifier. So 42 volts, so that makes it the plus minus 21 volt rails, which was in specifications for the maximum voltages of those filter capacitors. So okay, so we've got both supply rails. Excellent. Okay, so what's next? I suppose to verify that it's even got an output. And the easiest way I'm going to do that quickly is connect a pair of headphones and an input source like just the guitar lead with nothing connected to it, and just touch the end of it. Interesting. I don't actually hear a proper output. I hear a bunch of mains noise. Interesting. When I jiggle this input socket plug, it's very erratic. I'm wondering if we've got an issue with the socket. Right, I know you guys can't hear it, but when I push on this, all the buzzing and crap that's going on in through the headphones goes away. Then it comes back. I'm assuming that the actual socket itself at the PCB has a bad connection on the ground side, which is at the front of the socket. I mean, you might be able to hear that through the headphones, right? That sounds like a grounding issue. Now it's gone. Alright, so seems to me that's the only problem, is probably a bad solder joint. The only issue now is I have to pull the PCB out to fix it, which means I've got to take all the knobs off and the hardware. And it's a good opportunity to actually clean the thing as well, I suppose. But what I was thinking about this about 20 minutes ago is I am not happy with the fact that there is no inline fuse protection to this transformer. So if this transformer was to short, then, well, it would blow your circuit breaker or your fuse in your house or whatever it's connected to. These do actually have a thermal overload fuse in them, so if they overheat they'll go open. But that's only for thermal. It doesn't actually protect against short circuits. So I was thinking that I should add a external fuse just in line with the active. That's how it's supposed to be done. And as an Australian, this makes me very angry. This is supposed to be an Australian product, and it's not adhering to Australian standards or Australian electrical standards, or electrical safety standards is what I'm trying to say. So, yeah, that's kind of bad. So, anyway, what I'm going to do is I'm going to pull the circuit board out, which is going to be fun, and I'm going to inspect it and see what the problem is with that socket. It seems to be, I can get buzzing out of the end of the lead, and I did plug a bass guitar in there before off camera, and when I held the plug down so it's making good connection, I could hear the bass coming through the headphones. So the amplifier works. Just got to fix that connectivity issue. So it means I've got to bugger eyes around with that IC and the heatsink compound, etc. But it looks like it's only held in by the IC and the pot knobs and the socket knobs. So I'll get to doing that off camera because it's not really interesting to watch me pull hardware apart. Right, that was a challenge and a half. I had to unsolder the transformer secondary windings. I've marked them AA for the 2 white wires, C for the black wire, L for the LED's blue wire in the switch, and E for the big thick earth connection. And these knobs are really weird because they were very tough to get off. It's hard to tell whether these are supposed to be a round shaft or a D shaft. I mean, it is deformed, but to me that looks like it's supposed to be fitment for a round shaft. I don't know, but the pots that are on it are a D shaft. So, yeah, well, they've got all this extra hardware to space things out. They've got 2 thick galvanised washers, I think they're galvanised or stainless steel, 1 and 2, on each pot, so those are going to have to come off so I don't lose them. That's just to space it out from the front panel, and probably to limit the amount of thread that's coming out the front. So take those washers off. They've also got 2 washers per socket, also to space it out. So, but the build quality of this PCB is absolute junk. And that capacitor bent over like that's annoying me too. Right. So, well, there's an issue. We've got a dead spider. At least I think it's dead. I'll get rid of him in a minute. But I do see that there are solder joint issues around the socket here. And whilst I've got it out, because it's such a prick to take out, I'm going to go through and basically touch up all the solder joints, because I don't want to have to pull this apart again if I don't have to. But I'll get rid of my little 8-legged friend, who only looks like he's got 4 legs now. But anyway, with our 8-legged friend removed, there's a little bit of junk on this board. I don't know what half of it is. Looks like hair from a cloth, which is interesting. Right, so I'm going to touch up these joints. That one's actually cracked and open. That's about as close as I can get the zoom, but if you look carefully at this joint, when I find my screwdriver, you'll notice that it's cracked all the way around where it's supposed to be joined to the pad. It's very hard to see, but yeah, that'd be why we've got a ground connectivity issue, and when you actually push on the socket, in fact, you can actually see it moving when I move the socket back and forth mechanically. So yeah, there's our issue. It's always bad solder joints usually when there's connectivity issues. You would think, because of the fact that it's actually mounted to a front panel, it should be mechanically solid and it shouldn't break the joints. That one's really bad. But it does. I mean, there's no other mechanical support for this board. So yeah, and that socket over here isn't much better. That's the foot switch socket. So I'll make sure that that's connected physically, even though it's only using 2 connections. I'm not sure what all this hairy stuff on the board is. It's just, yeah, weird. Now this circuit board doesn't have a silk screen on the other side, but it does actually have all the connections marked on the back of the board, or the underside, which is annoying because you don't know what it is from the top. So there is that sort of idea there. That's not very great. So I'm going to go through and just touch up some more solder joints just to make sure. I might as well do the headphone socket whilst I'm here, because joints don't look too crash hot either. And then I'll reassemble it, and then I'll work on maybe adding some external fuse protection, because I still don't like the idea that there isn't any. Alright, so let me fully inspect this board carefully, and I will come back when I have got it back together, or some form of progress. Alright guys and gals, I've gone through and resoldered a few joints. There was a couple of issues with the pot centers. It does look soldered now, but it was a bit cracked, and the solder didn't look like it was taking properly, so I had to actually sock off the solder. Keep your mind out of the gutter. Extract the solder off of the connection and then just lightly file around the pin of the pots respectively, so that it was making good electrical contact with the solder. Now, before I put this board back into the chassis, I want to do 2 things. 1, clean the chassis, and 2, drill a hole in the back of the chassis to accept a fuse socket. Might as well do that with the circuit board out, so no drilling crap, metal and stuff goes underneath the circuit board and shorts things out. But I also want to test that I've actually fixed this. Now, that requires hooking it back up to the power transformer. However, I'm wondering if I can just get the power in off of my bench power supply by connecting it to the AC input here, and put the power supply up to its full maximum output, which is about 19 volt per channel, and just see if I have actually fixed it. So that's what I might do, but I've got to be careful that this IC cannot be run too long without a heatsink. I'm just trying to think of how I can heatsink that quickly. Actually, I could just probably put a TO220 heatsink just on it, just to temporarily. In fact, I might just do that when I can find one. That'll do, donkey. That'll do. It's good for testing purposes anyway. I now need to hook up the power supply, the 2 commons points, the positive of one supply and the negative of the other, to here, and each positive and negative respectively to here. However, I might just simply solder some wires on the bottom of the board to make it easier to connect, so less chance of shorting on things. Okay, I've got it hooked up to the power supply. It's turned on and it's loaded and connected to the circuit, and currently we're drawing around about 10 mA. I plugged the headphones in and turn the volume up, and I can verify that it is indeed working, and all the controls do things. I haven't tested the overdrive channel yet, which I'll do just now. You can hear it's distorted, so yes, that channel is indeed doing something as well. So excellent, the electronics are fixed. So now I can turn my attention to the chassis. The chassis has been cleaned, looks a lot better, and smells like I've just cleaned a toilet. I'm just using some of this Strike multi-purpose cleaner. I believe that's got a... that's what it smells like. Pomegranate and vanilla. So it smells like a fruit and the arse of a beaver. Okay, anyway, back to reality. I have cleaned the inside a bit as well. I'm going to have to mark and drill a hole to accept the fuse socket, which is 12mm in diameter. And it might be an idea to wire all that in before I put the circuit board back in. It's just easier to get to that way. And yeah, then reassemble all the hardware. However, I've got to wait for J-Car to open, which is not until 10 o'clock today because it's Sunday. There's a bit of damage here on the front panel. And it's only like 9 o'clock, so I've still got about an hour. So I'll get the hole drilled. We now have a hole in order to accept an M205 panel mount fuse holder. Now you may be wondering what size fuse, not physical dimensions, amperage rather, fuse should we use in this. Well, it's only a small transformer, so I'm going to say a 1 amp inline fuse will be fine. I don't see it drawing that much current. As for the actual current draw in watts of this thing, probably no more than about 30 watts. The TDA2040 probably outputs about 20. I will put it on a scope before the end of the video and we'll find out. But yeah, I reckon a 1 amp fast blow fuse will do fine there. I might even have one, but I'm going to buy one anyway. So next thing to do is I'm just going to clean out any crap that's on the inside of that, and then I'll turn my attention to the cabinet whilst I'm still waiting to go out to the electronics store. I also need to pick up another line cord. What I'll do is I'll go to the tip shop first and just look for, like, you know, an old computer cable, like IEC cable, because I don't have a spare one, and I'll just cut the IEC connector off and rewire it with the fuse. And a short time later, the cabinet's been completely cleaned. It looks a lot better than it started, and I even cleaned the front grille. It's all been stripped down, taken the driver out, dusted that out. This hole here that mounts the grille is stripped, so I'm going to have to like shove a matchstick in there and glue it, just so that when the screws go back in, it's got something to grab to. But of course I'll have to let the wood glue dry for at least an hour, something like that. All the other holes are fine, they're not stripped, and it's really starting to smell like a toilet in here. Like I mean, like I've just cleaned one. Whew. Yeah. So this is a good look at the driver that they're using. It's a Pro Power Super Series loudspeaker, 25 watt RMS and 8 ohm impedance. So yeah, I reckon this amplifier is about a 20 watt. As I say, I'll put it on an oscilloscope, measure it, and we'll find out. But yeah, that's the loudspeaker. Nice. And it's a very stiff cone. These are not hi-fi speakers. These are specifically designed to be used with guitar and bass because there's very little suspension movement. Hi-fi speakers have a lot of suspension or excursion movement, and you can actually force, with a bass guitar especially, you can force the cone to overexert out that way, and then you end up with a cracking, distorted sound when you hit the bass notes. So having a stiff cone like this is, well, key to the musical instrument amplifier industry. So if you ever have to replace a driver, this is about 6.5 inch, don't use a hi-fi speaker, you will be very disappointed. So I'm not sure what this would be worth for a 6.5 inch driver like this. Maybe $100. Depends on the brand. You could put a Celestion in here if you wanted to. But anyway, moving on. Alright, so to fix this stripped out hole, I'm just going to take an ordinary match. Well, this is a barbecue match, but it's good enough, it's thick enough. I'm going to put a little bit of PVA on the end of the match. Right, if I can get some out, it'd be nice. Like that. It's probably a bit too much, but that's fine. And I will shove it in the hole. Like so. Get some of the excess off. And I'm going to leave it like that for a while, and when I'm ready to screw the grill back on, I'll just simply snap the end off or cut it with a knife. But I've got to let that glue go off for at least an hour or two. I just want to make note of just one little thing here. The compound that they put on the back of this IC was not done right. There's hardly any on the metal tab part up here. And the same is also true for the mica washer. There's absolutely bugger all there. So yeah, that's real good. So anyway, I've got to clean all this old compound off, and so I can apply some new stuff. That and the mica washer. I'll go out to J-Car, buy the fuse holder and fuse, wire up the mains properly, and yeah, pretty much reassemble. And a short time later, well actually about an hour later, I've gone out to J-Car and bought all the stuff I need. An M205 fuse holder, panel mount. I've got two 1 amp fuses, fast blow. I always get two fuses when I buy fuses just in case one blows for some reason. And a brand new power cord with bared ends. That was only about $8. So I thought I might as well buy a new one rather than mess around with an IEC cable cutting the end off and stripping it back, etc. So I'm going to probably make myself a cup of coffee, and then I'm going to install this new cable and other hardware. The other good thing about these cables is it comes with the eyelet already for the earth, so I don't have to worry about messing around with that. So I'll get to doing that. I'll come back when it's all completed. It never happened. We made it up. Yeah, all I've got to do now is just tidy these up with cable ties, but first I'm going to check the continuity. I haven't quite got that heat shrink done correctly at the bottom of that, so I'll fix that up quickly. Okay, the power switch is off, so I'm going to do a quick continuity test. So I'll turn the power switch on, and as we can see, once it ranges, we have got about 62 ohms there, so we are now seeing the primary of the transformer. And if I undo the fuse and pull it nearly all the way out, we should see nothing, which is correct operation. So now I've got to get the bastard back in there. I'll fix it up in a minute. Anyway, so that's continuous through the power cord. I'll just check the earth connection, make sure that that is continuous, which it is. So it's earth to the chassis, no problems there. Right, so I can now put my fuse back in properly, tidy up this wiring, gravity, with some cable ties, and then put the circuit board back in and re-grease the washer, re-isolate it, and yeah, come back when I've done that. There, it's like I bought one. It's all back together. I haven't put the knobs back on yet. I'm going to test it first. Yeah, everything's back together. It's all wired and cable tied and wired in the correct places. So all I've got to do now is plug it back into the dim bulb and test out the operation of the unit first, and then, well, connect it to the oscilloscope, I guess. Alright. Stand by for blowing up and laughing. Bang! Ha 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 ha! No, it's good. There's no unusual current draw on the dim bulbs, so there's no short circuits. There's no magic smoke anywhere. So I'll just verify that I can hear some static coming out of the headphone socket, and then I'll connect it to the oscilloscope. Yeah, I can hear it. There's noise there. Okay. Sweet. Okay, I've got everything set up, DDS, oscilloscope, dummy load, etc. Currently at 1000 Hertz or 1 kilohertz, so I'll turn the power on, and nice. We have an output signal, which is nice. So I'll just twiddle some knobs. Yeah, it's increasing. Let me drop the voltage per division down. It's still on the dim bulb currently, so I can't go too high. So let's see what the treble control does. Nice, that's doing something. A bit noisy. That's the middle control. Yeah, it's doing something. Bass control, well, won't have much effect, but it is doing something. Let me take this off the bottle, i.e. dim bulb, and plug it directly in and do some power measurements. Right, so it's off the dim bulb now. I'll just make sure nothing's going to go off with a bang. Nope. Okay, so we have a signal output. I'm not sure what I'm putting in at the moment. I'll drop that down. It is ringing a little. That's going to be clipping right there. So yeah, it's not very stable. We're putting at times 10 roughly 47 volts peak to peak, which is nice, or 16.5 RMS. So we're going to say 16.5 RMS. So that's 16.5 multiplied by itself equals that, divided by the load, 34 watts. Okay, that's not too shabby. That's also with ringing on the signal. It's not very clean, but 34 watts RMS. That's quite astounding for the TDA 2040. But nice. So I guess the next thing to do is I'll hook it back up to the speaker and the cabinet and everything and do a final test. There's not much else I can do with this. I know it's working, as we can see there. So alright, let's try it out. Get some bass. Alright, let's try. That's treble. That's middle. Perfect. Well, we can safely say it works. So I'm happy, and that's where I'm going to leave this video. So if you enjoyed it, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is Yastro30 saying see ya. Have a great day. See you in the next one.